Hey, hey! Going through with animation. I'm going to tell you a story. So about 3 years ago, me and my wife decided to adopt a puppy. And this is Blizzard. So we got him when he was really, really tiny. But as time went by, he grew larger. And he grew larger. And he grew larger still. And he grew larger, and then winter came, he became a horrible direwolf. He likes to run around, he likes to jump. And I'm going to show you a video of Blizzard jumping. And I want you to look at his ears. And by looking at his ears, if you understand what's going on there, you'll understand everything that I'm going to talk about here. So are you ready?
Yeah.
You don't sound like you're ready. Are you ready?
Yeah.
Okay, cool. Okay, I'm going to show this again for those of you who didn't catch it. Look at the ears. Okay, thank you. Goodbye. I want to take you back to a time in 1994, where this is how I looked. No, but seriously, my name is Opher, and I'm a creative developer at Echo, which up until last year was called Interlude. And what is a creative developer? It's just a fancy name for front-end developer for people who don't know what front-end development is. I work with game designers and filmmakers to create interactive videos. But we're not going to talk about that. We're going to talk about the year 1994, where The Lion King came out. So The Lion King is a Disney movie where I saw it when I was 10, and I think it was a turning point for me, because it was the first time where I saw an animation movie, and I finally got to understand the scope of breadth of working with animation. I mean, Disney did an amazing job with this movie. It's incredible on many, many levels, but specifically it's animation. And true, The Lion King wasn't perfect, by no means. It wasn't Disney's most original movie either. But there was something about this movie that managed to take drawings of things that aren't real, and convey so much emotion with just a series of pictures, essentially. And after seeing it, I started asking myself, how is it possible to take drawings and make them convey so much emotion? It's a complex question. In 1981, two of Disney's 9 old men, which are the original animators of Disney, issued out this book, The Illusion of Life. And in this book, they lay out 12 principles of classical animation. These principles are squash and stretch, for example, staging, arc, secondary action. We're not going to go through them because going through all of these will take an entire curriculum of classical animation studies. But I want to focus on one in particular, and that is follow-through and overlapping action. So essentially, if you have a character, follow-through and overlapping action means that some part of it is either continuing to move after the character stopped or starts to move after it started. For this, in this example, the cape. In this example, the leaf of the carrot starts moving with the carrot, but continues to move after the carrot stopped. This is the follow-through. The overlapping action or overlapping motion is the way in which the carrot and the leaf move in different speeds. So these two things together work to create a sense of liveliness, of life, actually. So if you look at the carrot, for example, you can see that the leaf starts moving way before the carrot. And when it stops after the point where the carrot stopped. So essentially it goes forward after the carrot. And this helps convey a sense of mass. In these two examples, you can see that one looks like it's something stiff, and the other looks like it has more springiness. at this example from the coma space, there's this dragon. And as he jumps, you can see that when he reaches the apex of the jump, the tail still moves upwards. In this example, this is a character for a game I like called Overwatch. You can see as the character, her name is Mei, moves, her clothes move after her body stops moving or moves in the other direction. And also the wire coming from the gun. It gives this sense of happening to it. We were talking about Game of Thrones. This is an Israeli animator called Ran Mendel who does amazing things. Specifically, I like in this animation the way in which his little tiny bit of hair continues moving after he chops off the head. He did one for every episode, and it's amazing. You should really check out his stuff. I showed you animations and characters, and that's cool, but we're here to talk about web development, so what does that have to do with anything? Well, turns out there's a lot you can learn from classical animation about designing for the web. Let's take a look at this example. You see, there's a dialogue here. And this is from Codrops, by the way, a site with a lot of cool examples. And as you open this dialogue, you see the window kind of floating in like a Roadrunner thing where it just swoops in and then swoops out, which is pretty cool. It gives us some sort of character to a model window, which is like the most boring thing you could do. In this example, you have another model window, and as I stop dragging this, I drag and hold, you see the buttons stagger back into place. And again, it gives us some sort of character to this window. But staggered motion is not something that is only good for demos. This is an example from the Google material design page where they talk about the choreography of design. So this is in red because this is what you shouldn't do. If you want to display a grid, for example, don't have all the elements appear exactly at the same time, because that's confusing and disorienting for the user. So Google says, what you should do instead is let them appear in a staggered motion, in a staggered fashion. You see, they appear one after the other. So it's not me telling you to do these things. Google agrees with me, and we're in their building, so This is from mobile design. And you can see that as this card opens, first the animation of the header is the one you see, and then other elements pop into place. Let's take a look at another example, and you can see the same thing. So your card opening up, and only then the other elements start appearing one after the other. Okay, so staggered animation or overlapping motion is cool. I want to show you something that I did and how I went about doing it. So this is something I did at work. It's a loader spinner thingy that loads up and tells the user that something is happening, that the project is loading, so that he doesn't get bored and close the window or whatever. You have 3 dots following each other. That's pretty much it. And it looks simple. And in a sense, it is simple, but it's not straightforward. So let's take an inventory of what we're doing. We have 4 circles. Why 4 and not 3? Because you see 3 circles, and the first one exits stage right, and as it exits right, the last one enters stage left. So you see 3 circles at any given point in time, but you need 4 circles to make the illusion happen. The total iteration time for one of these movements is 1 second. The movement time for each specific circle is half a second, and the stagger time, that is the time each circle waits between circles, the movement, is 0.15 seconds. Cool, that's what we're working with. So I'm going to show you 2 ways of implementing this. One is with CSS, yeah. And the other is with the green sock animation library. I put in a little asterisk at the bottom that says Web Animation API because this is something really cool coming to browsers soon as people actually implement them. And that's a way to make animations in a much more controllable way. Right now, as you'll see, it's a bit not as straightforward as we'd want, but in the future, this is something cool coming to the browsers. The best thing, like the guys at PowerTune said, is that you get good performance across the board. It doesn't matter if you're working in a desktop, on a mobile, on a really old mobile, on your mom's mobile, it kind of works if someone did it right. If you use the proper CSS attributes like transform instead of positioning, opacity, and you don't try to animate things that change the layout. If nothing of what I just said makes sense to you, don't worry that there's a lot of material about that on the web. And the animation is defined using CSS. So the CSS you know and hopefully love. So it has cons though, and the first is that there's a limited amount of things you can do with CSS animations. They're just like the API is not as robust as you'd like. And that means no dynamic animations. What are dynamic animations? For example, throwing a ball at something and having it bounce, but differently depending on how you threw it and the velocity and the physics or whatever. You can't do that with CSS because that's dynamic. That's dependent on user action. And CSS animations are hard to debug. The dev tools are getting better and better, but they're kind of hard to debug. How do we go about doing that? Let's do a really quick recap on CSS animation. You have the keyframes, word, attribute, whatever. You specify percentage, and for each percentage, you specify what goes on in that keyframe. So here we have 3 keyframes, and for each of those, the little circle span moves infinitely for 2 seconds. But let's take a look at naive implementation. And that means without any staggered motion, staggered animation at all. So you have your keyframes where every little span moves from 0 to 60 pixels. So it works, but it kind of looks robotic. Like everything moves very rigidly. So let's try implementing staggered animation like I showed you. We do that by adding animation delay, right? Because we want every different span to have a little delay. Let's go down there, and the first one gets a delay of 0 seconds, the second one gets a delay of 0.15, the third one gets a delay of 0.65. Okay, cool. Let's see how that works. Yeah, so that didn't really do what we wanted it to do. And the reason is that animation delay doesn't affect every iteration of the animation. It only affects the first animation. So essentially what just happened is that the first circle moved, then the second, then the third, but way before the second ended, the first started again, and again, and again. And then this is not at all what we had planned. So what does that mean? We can't do that with CSS? We can, but it needs a little trickery. Let's see what we want to do. So this is a chart of what the animation that we want to do. So it starts at 0 seconds and ends at 1 second. That's one iteration. Let's take a look at the second circle, for example. So we have 4 keyframes. The first one, where it doesn't move at all, that's this one at 0. Translate x, 0. So we know that. That's 0%. That's easy. The last one is when the animation has ended. That's 100% and translate 60 pixels. The third one and the second one are where the animation actually happens. So between the second keyframe and the third keyframe, the animation moves between 0 and 60 pixels. But what are the percentages here? Like off the top of your head, that's kind of hard to know, right? So let's do a little bit of math. Don't be alarmed, it's just a little bit of math. Okay, so first keyframe, easy. 0 seconds, 0%. Last keyframe, also easy. 1 second, 100%. Okay, let's talk about the second keyframe, this one. So we want it to start at 0.3 seconds because it's twice 0.15 seconds, this part. We divide it by 1 second, which is the total number of total time, and multiply by 100, we get 30%. Then for this one, it's exactly the same, but we add the animation time, which is half a second. And then, punch it into the calculator, and you get 80%. Cool, so we have all our percentage, and we know what to put in the keyframes. And here's the solution. I'm not going to make you go through all this code, but it has 2 parts. The first one is a mixin, a SASS mixin, which kind of does this calculation for you. This function takes which circle, this is I, what is the animation time for each circle? We set it half a second. The total time is 1 second, and the delay 0.15 seconds. That's all things that you input in. And it does the exact same calculation that I just showed you a second ago. So for 0%, nothing, for 100%, nothing, and for those two keyboards, this is the exact calculation I just showed you. And then how do you use it? Plug in your variables, do a for loop, and for each for loop, you create essentially a new animation, one for each of the spans, and then for that specific span, you give it this animation. So you have 4 spans, 4 different animations, and one SASS mixin to do the hard lifting for you. It looks awesome. This is the part where you clap, because it's like, CSS, woo! Math is hard. So if like that went over your head, or like it takes even me, not even me, it sounds pretentious. It takes time to think of these things. There's a library that helps called Animate. It helps with doing repeatable animations, and also a bit with staggered animations. So it's a cool SASS mixin that you can use, and I recommend you check it out. It's by Will Stone. And let's go towards the other way of implementing, and that is with GreenSock. What is GreenSock? GreenSock is an animation library that in JavaScript that has a really cool way to make your animations programmatically. So let's take a look at the pros and cons. First, it has an amazing API. You can do everything with it. And the fact that you can do everything with it means that you can do dynamic animations, physics. It even has some helpers to do physics and other cool things. And it handles browser inconsistencies. This is specifically relevant if you're doing animation with SVG. And SVG is notorious for like every browser deciding to do completely different things. And kind of GreenSock kind of ties it all together in a nice way. But it's not perfect. JavaScript is implementation sensitive. So that means that if you're doing awful things with your JavaScript and then using the same JavaScript to make animations, your animations are going to be awful. So it kind of puts the weight on performance on you, the developer, and also on whoever is implementing the device you're watching on. So for example, you make your website and the person watching your website uses a browser that is a specific port of Chrome that the phone manufacturer decided to put in, and in that specific phone, the JavaScript engine works worse. So you get those things. It's awful, and your animations are now in your JavaScript. And if you love JavaScript, that's cool. But if you love separating your animations from your logic, that's less cool. So how do we do this with GreenSock? There's also a trick to this. And let's take a look. And we're done. Yeah, this is all the code needed to make this thing work. And let's take a look at it. So GreenSock has a cool concept called timeline, which is really similar to how Flash used to work in the day, where you can kind of bundle animations together, one after the other, and it runs it for you. So here I create a new timeline and set its repeats to -1. So it repeats exactly not one time. No, it means it repeats indefinitely. Then I set the initial condition for all these spans, which is putting the x value at 0. And then I use this really nifty function called Staggered, which takes all the different elements and makes them animate one after the other with a delay. You give this function the the values we talked about earlier. Span is the selector for all the spans. So just that we're talking about the same thing. These are the 4 spans for the 4 circles. 0.5 is the time for the animation, and x is how much you want it to move. -15 is the stagger time, so you want it to wait 0.15 seconds. And then there is this weird line which tells it at time 1, set empty object to empty object, which is a weird way. Yeah, what? This is the official way in GreenSock to let it know that at time 1 it needs to do something. So it artificially extends the timeline to 1. So if I didn't do this, the animation would end as soon as the last circle animated, but this makes it wait a bit more until the time 1 has passed. And then until to play. So you see, this is again a much shorter and concise way of doing the same thing, but it comes at a cost, the cost of JavaScript. So again, if you're blocking the main JavaScript thread and trying to animate, your animation will not work. The cool thing about having your animation programmatically is that you can kind of control it after it has started in an easy way. In the next example, I can take control of the animation direction. So at any given point in time, I can click and reverse it, which is really nice if you want to actually control how your animations perform. So in a real-world scenario, this would work where you have like one animation, I don't know, a card opening up, and then your user, because they're annoying, would start clicking on other things in your app, and you need to stop the animation, start another animation, go to a different animation, stop that one, and it's harder to do those state switches with CSS. GreenSock allows you to do that more easily. Cool. So we saw 2 different ways of implementing this little loader spinny thingy. That's the official name. And which one is better? None of them are better. It's really specific to your use case. So sometimes you want to make something that loads as fast as possible. In the case of a loader, that makes sense because you don't want to load something that tells you that you need to wait to load something. So CSS would be a good choice, but sometimes you need to make more robust animations and you don't want to pull your hair out more than you have to. That was it. Thank you for listening. Me and Blizzard, thank you.